Excellencies, dear friends, welcome back everyone. The second part of our special session focuses on the international Arctic science cooperation. Our theme for this segment is Science Meets People, incorporating human in Arctic sciences towards knowledge, co-production and application. And there should be a QR code available through which you can download presentations. This session will be kicked off by 2 keynote presentations, followed by a discussion. I am pleased to introduce our first keynote speaker, who is Dr. Tore Hattermann, section leader of Oceanography at the Norwegian Polar Institute. Dr. Hattermann, the floor is yours.
Thank you very much for giving me the opportunity to present on behalf of the Norwegian Polar Institute, where I am based, which activities Norway is currently conducting and has been conducting in the past for monitoring and doing research in the Arctic Ocean, in the Arctic regions. I'm myself a physical oceanographer by training, so I will talk mainly about the marine activities, but there would be more to mention. I just squeeze in what I think is most important in these 10 minutes. How do I advance the slides? Thank you so much. So traditionally, coming from the Northern Europe, Norway's activities have been entering the Arctic through the Fram Strait Gateway and the Svalbard archipelago, which is under Norwegian administration today. And that is where our long time series have been built. You see these stars in the circle on the map. This is our Fram Strait Observatory, where the Norwegian Polar Institute has been operating moored sensors for more than 30 years. And there's just one example of a time series in the top that shows how the temperatures in the outflowing waters from the Arctic have been rising over the years with more and more warmer outflows as the Arctic is warming up. Now, almost 10 years ago now, a new ice-going vessel was introduced in Norway, the research vessel Kronprins Haakon, and with that a new era started for Norwegian Arctic marine research, which enabled us to get into the central Arctic Ocean. And then we have now established and extended our activities further north to almost all the way to the North Pole, along this red dotted line, which, with regular cruises that are now conducted, and also moored observatories continuously recording ocean data, multidisciplinary ocean data. Just one example of our recent cruises where we enter or where we start from the Svalbard continental shelf region, observing the warm Atlantic water inflow into the Arctic Ocean, and then moving towards the Nansen Basin, crossing the Gackel Ridge and into the Amundsen Basin, looking at the different water mass properties, the stratification, and also, as you see on the picture on the right, collecting in situ water samples for chemical, biological, and pollutant analysis. Now, a lot of the long-term monitoring at the Norwegian Polar Institute is based on observatories that are moored in the ocean year-round and visited once every year, once every second year. And now we have established such observatories in the Central Arctic Ocean with a 4-kilometer deep mooring with multidisciplinary sensors, providing first the basic of the physics, the ocean currents, and the hydrography. Data from these instruments look a little bit like this. This is really my playground. I love to explore this data, as well as the hydrography showing how temperature and salinity are changing over time, but also more sophisticated sensors like these looking at the sea ice thickness evolution over time and sea ice drift, sea ice roughness with acoustic sensors. And this is an example of the same type of data that has been collected in the Outflow Observatory from Strait since 1990, so more than 30 years, which is showing a dramatic change happening in the early 2000s, that the sea ice has changed from being thick and multi-year ice to thin and uniform sea ice, indicating much shorter residence time of the sea ice in the central Arctic before it is exported and melted along the East Greenland current. We are also moving more into the biological field and also collecting water samples automated on these moorings you see on the picture on the left, as well as the sedimentation to observe the carbon export that is produced by the ecosystem when it's building matter in the ocean surface and sinking down to the seafloor, which is an important parameter to close the global carbon budget. This is an example which I would also particularly highlight for opportunities for pan-Arctic collaborations with the Korean Polar Institute. Passive acoustic recorders give us information about the marine wildlife, the marine mammals, whales and seals. Walruses leave their sounds on these recorders. We can map where they have been, and we can also observe how changes in shipping routes and human impact can affect these species. Of course, the standard pelagic biological sampling based on trawls and in situ analysis of net samples, as well as acoustic monitoring with echo sounders en route when the ship is doing its transect is a standard procedure that is included in these cruises. We also, to understand the changes of the sea ice, we need to describe the sea ice correctly in the models. Most of the sea ice physics today in the global climate models is still from the 1970s, thinking of large-scale models that do not resolve the fine scale. If you take a look at this image of the actual sea ice, you see that sea ice is not uniform, but changing on scales that are much, much smaller than this vessel that you see on the picture. These processes are not adequately described in the sea ice models that we nowadays use to predict the future sea ice decline. Improving those physical descriptions in the models is hence a crucial requirement for getting better predictions, both on the long time scales, but also for short-term assessment of ideal shipping routes or whatever. This is more of an example of our activities around the Svalbard archipelago. I said NPI has been working there also for more than 30 years. Again, in the recent years, we have established moored observatories that look at the Atlantic water inflow that shapes the ocean, ice, and atmosphere interactions north of Svalbard. You see this arrow going into the upper right figure. This is where the sea ice melts because warm water is entering the Arctic from the south. Vice versa, this water is recirculating onto the continental shelf. You see on the upper left, the red triangles on the map is from another moored observatory that shows how this water is recirculating back and influencing the retreat of the Austfonna ice cap, which is outside of Greenland, the largest glacial ice cap on the northern hemisphere, where frontal ablation, the tracking back of the front, is directly correlated with the ocean temperatures that we observe at these moorings. On the west side of Svalbard, where the Ny-Ålesund station is based and also the Korean research station is based, in the Kongsfjorden fjord environment, we are running annual cruises. Currently, there's a specific activity ongoing where we do weekly cruises all year round to get the seasonal picture, but also longer monitoring of the biogeochemistry in the fjord. We have a decade of records of the CO2 content in the ocean waters, ocean acidification, again with ongoing collaborations with collaborators from the Korean Polar Research Institute. How to put this into a bigger perspective, you see that there are several countries pushing observatories, doing good, sound research in the Arctic, in different areas of the Arctic, and we really have to exploit the additional value by putting those observations together. This is a task for us scientists to integrate, which requires good partnerships, trust, and working together on these activities. Currently, on the European side, there is a large European project ongoing that is meant to establish an Atlantic-Arctic distributed biological observatory. In the future, and also already now, we are and we have to think pan-Arctic to integrate these data sources. Just for a horizon scan, currently in Norway is building on a new national initiative after the Nansen Legacy project has come to an end, which was by financial volume the largest national research effort that Norway has so far conducted. And this will be called the Arctic Ocean 2050, a follow-up project which is currently being shaped up, extremely multidisciplinary, extremely trans-institutional within the Norwegian research community, including several universities, the Norwegian Polar Institute, other large research institutes. This will shape Norway's Arctic research into the future. A final word, since COPRI has also a long-standing activity history in the Antarctic. I know several Norwegian researchers who have been on the Aron in the Amundsen Sea. On the other side of the continent, Norway is now also maintaining observatories in the Southern Ocean, and also since 14 years with moorings under ice shelves, a common interest type of work that COPRI is also conducting. So I'm also looking forward for these kind of collaborations in the future. Thank you so much.
Thank you so much, Dr. Hattermann, for sharing your expertise with us. Next on stage is Dr. Michael Linden Fernle, who is an astrophysicist and chief advisor from the D2 Space in Denmark. Dr. Linden Fernle, the stage or the screen is yours.
Your Excellencies, ladies and gentlemen, good afternoon, and thank you very much for giving me this opportunity to present here today, even though I'm not able to be present in person. What I'm going to talk about is some of the research activities conducted by the Technical University of Denmark in collaboration with international partners, but also a perspective that I would like to highlight during my presentation is the issue of engagement, meaning local engagement, engaging local entities, local organizations, and local population, not just in order to raise awareness about the research activities, but actually including locals into the research projects as far as possible. What you see here is a map of the Kingdom of Denmark, consisting of Denmark on the lower right. In the middle, you have the Faroe Islands, and then you have Greenland. And my focus here today will be on Greenland. Greenland is, as a part of the Kingdom of Denmark, an area which has a huge interest within Arctic research for obvious reasons. You have a lot of research opportunities within the Kingdom of Denmark in Greenland, studying the cryosphere, studying the effects of climate change, but there are also other very interesting research areas, as I will touch upon later, namely what we call space safety. The effects of solar weather are particularly intense at high latitudes within Greenland. One thing that is important here, Greenland has a very small population, less than 60,000 people in total, distributed around, most of them living in the capital of Nuuk. But you have to remember that these people, they have been living there all their life. They have a deep knowledge of nature. They have a deep understanding of how nature is working. And therefore, they are natural participants in research projects where you can use this expertise that has been gained through not just a lifetime, but through generations. One way to engage with local populations is through role models. What you see here is the crew of the Crew 7 mission that went to the International Space Station in August last year. In front, you have the Danish astronaut Andreas Mogensen, who went to the International Space Station for his second stay from August last year until March this year. Andreas Mogensen has been doing a lot of research, but another thing that he's been very aware of is to include the entire kingdom of Denmark. So in June this year, Andreas and myself and some of our colleagues, we went to Greenland to use time for Andreas could tell about his mission to the International Space Station, to share his experiences, but also to inspire people. We used the opportunity to have discussions with local entities, authorities, local population about how space could be of more benefit for the Greenlandic society, which business opportunities are within the space field, which can be exploited for companies in order to create growth. This was a very inspirational trip, and you can extrapolate that. So every time researchers, they go to places like Greenland, they should use time in order to engage with the local population, to tell about what is their research about, so that are not just coming in, doing their research and leaving again, but engaging with the local population, even though they are not directly involved in the research, but engaging and trying to pervade what is this about and how does it benefit us all. This is the city of Kangerlussuaq, which is situated between the cities of Nuuk and Ilulissat. Until recently, it was the main international airport of Greenland, but that has changed now. Now this function has been taken over by the capital city of Nuuk. This means that for the city of Kangerlussuaq, the need of finding other ways of supporting the population in order to find jobs, in order to find activities to support, have to be identified. So the municipality has been very focused on the need for finding new activities. And here research comes in as a natural thing. Research can be supported, and it already is in Kangerlussuaq, but an increase of activities is an obvious thing to do. You see a map here, you can see Kangerlussuaq to the right of the image. Going out to the sea, you can see the city of Sisimiut. In Sisimiut, the Technical University of Denmark, we have a campus where we do teaching, Arctic construction and geodesy and other types of research. We are expanding that right now. We are expanding that together also with the municipality of Kangerlussuaq, because one area where there's an interest in the local population in between local authorities is the use of unmanned systems or drones. This has partly been inspired by a collaboration with the Korean organizations, the Korea Aerospace Research Institute, KARI, and the Korea Polar Research Institute, KOPRI. This collaboration with DTU Space started back in 2018, where initially KARI and DTU Space made a memorandum of understanding to conduct technology tests in order to facilitate the use of unmanned systems under Arctic conditions. In 2019, KOPRI entered this collaboration, and during the years 2021, 22, and 23, these organizations conducted flights of drones doing detailed observations of glaciers in the Kangerlussuaq area. This collaboration has now been expanded. Right now, a new memorandum of understanding is being signed between KOPRI and the DTU Space to continue this very good international cooperation. This brings activities to the area. This brings researchers to the area who want to use the opportunities that this area provides for studying the effects of climate change. This has also been leading to an inspirational activity, namely the establishment of a drone test center in Kangerlussuaq, which is a collaboration between local authorities, the local municipality, but will support visiting scientists and companies who want to use this area either for research or technology development. As I mentioned initially, there's another area of interest. It's called space safety. It's the consideration of the threats against our society, against our civilization from space. You have 4 threat areas: the effects of the sun, the space weather, asteroids and comets that can hit our planet, our man-made problems, space objects and space debris, and finally particle radiation. What we do at DTU Space, you can see the actions that we take. We try to identify, understand, monitor, and finally also to mitigate the effects of this. This is not something that can be done by a single institute or even a single country. This has to be a broad international collaboration. And we've been in dialogue with several organizations and entities, also in South Korea, in order to strengthen such international collaboration. It's all about the sun's activity when we talk about space weather. And as I said initially, the effects of space weather are particularly profound in the Arctic region. What you see here is images of the sun from April this year, May this year, where the sun erupted with very violent eruptions. This causes beautiful northern lights, but it also causes disruptions in radio communications, can cause disruptions in power supply, in satellite navigations. At the Arctic latitude, we are running several projects where we are monitoring these effects, and we are doing it both from space, using the European Space Agency Swarm mission, where we have the scientific lead and have been providing key technologies for this mission, and also ground-based systems. We have a chain of both GNSS receivers receiving signals from the satellite navigation signals, and also magnetometers measuring the disruptions in the magnetic field from the solar activities. All this, combined with observations, local observations, can be of immense value in order to estimate the effects and also increase our ability to predict the effects, example given on navigational issues in the Arctic. The issue of space debris is ever increasing. The number of space objects is increasing at an ever increasing pace. You can see here on the graph here, the blue solid line is the number of spacecraft orbiting Earth. Right now, we are working towards 14,000 operational satellites. The dotted line shows the number of fragments in orbits. Here, especially a number of events in 2007 and 2021 stand out. These were deliberate actions where China and Russia, respectively, they conducted an anti-satellite test, shooting down one of their own old satellites to demonstrate this capability. The event in 2009 was a collision between a defunct Russian Cosmos satellite and an old Iridium satellite. This just to show that this is an ever-increasing problem, and our modern society cannot function without access to space. So we have to be better at monitoring and maintaining a safe access to space. Right now, we are conducting several projects. One here, you can see myself here in Kangerlussuaq, where we have now placed a 0.5-meter telescope in order to track space objects. This telescope is able to be remotely operated from Copenhagen, but in order to operate it and do observations of space objects and space debris, the telescope has to be prepared for observations. This is where we have engaged with local authorities and local entities in order to have this collaboration so that they prepare the telescope for operations. We operate the telescope, we gather the data, and they then prepare the telescope for the next observing run. This is just one example of how you can engage with the local entities and organizations. And it's very important that the local populations, they gain ownership of the activities that are going on. Of course, the research projects will typically come from the outside. They will be funded from the outside. But as much as collaboration is possible is of value for both the researchers coming to Greenland and for the researchers and the entities and organizations and the population living there. So my recommendation here would be the more, the merrier. The more we can engage, the more we can interact, the more we will gain, both on the scientific level, but also on the personal and the human level. Thank you very much for your attention.
Thank you, Dr. Linden Fernle. Now, through these two presentations, we learned about research collaboration, on how that can be put into the bigger perspective, but also on the importance of engaging with the local populations. Now we will move forward to a roundtable discussion, and I'm pleased to introduce to you our chair and panelists. First, the chair of this roundtable discussion is Dr. Hyung-Chul Shin, president of COPRI. Joining us as a discussant is Chin-Young Chung, principal research scientist at the Division of Ocean and Atmospheric Sciences at COPRI. We are also pleased to have with us Dr. Yong-Chik Chung, who is the senior research scientist at the Center of Remote Sensing and GIS at COPRI. With us also, we have the head of Greenland representation at the Embassy of the Kingdom of Denmark in Beijing, Jakob Isbosetsen, and Dr. Chon-Yang Wang, who is a senior research officer at the National Research Council of Canada. Mr. Chair, the stage is yours.
안녕하세요. 방금 소개받은 신영철입니다. 앉자마자 35분에 끝내야 된다고 해서 효과적으로 진행해 보겠습니다. We just heard 영어로 하는 게 맞다고 하지 않았나요? 네. We just heard from Tore Hartmann and Lyndon Vernell as an example case of Korea, Norway, Korea, Denmark, Greenland research collaboration. I'm delighted to have Chin-Young Chung and Yong-Chik Chung, our COPRI staff scientists, and Minister Isbosetsen, who will speak about the utility of science in Greenland. And Dr. Chon-Young Wang is here.
Yes, hi.
Yep, okay. About the Arctic knowledge co-production and application. Perhaps, although Arctic science and Antarctic science share a lot, have a lot in common, but maybe the biggest difference is Arctic science just has to collaborate with local community to do their science. And also, collaboration may be the most advanced and noble form of human behavior. So my first question goes to Dr. Chin-Young Chung. You heard Tore's presentation about an extensive mooring network and observation system in terms of effective use of resource, methodology standardization, and data gap filling, how we should international collaboration and how this international collaboration can enhance current existing efforts, please.
예, 말씀하신 대로 지금 국제 협력은 연구 자원의 효율적인 활용 그리고 데이터의 신뢰성 강화 그리고 이 모니터링의 격차를 메우는 데 매우 중요한 역할을 할 수 있습니다. 현재 일반적인 북극 연구는 각 나라가 개별적으로 수행하고 있기 때문에 연구 자원 그리고 선박 그리고 연구 장비 등이 다 분산되어 있습니다. 그렇기 때문에 그리고 광범위한 계류 네트워크와 다양한 장비를 운영하는 것은 대규모의 투자가 요구되기 때문에 국제 협력을 통해서 물리적인 자원과 인프라를 공동으로 활용한다면 연구비를 절감할 수 있습니다. 예를 들어 특정 연구에 투입되는 연구 선박이나 연구 장비를 공동으로 활용한다면 그 절감된 연구비를 다른 연구의 어떤 확충에 투자한다면 연구를 더욱 효율적으로 수행할 수 있다고 생각합니다. 그리고 국제 협력을 통해서 인력 교류가 활성화된다면 서로 다른 배경의 연구자들의 협업을 이끌어낼 수 있고 그리고 서로 다른 지식과 기술의 교류가 가능하기 때문에 보다 창의적이고 혁신적인 연구 결과를 도출해낼 수 있다고 생각합니다. 그리고 두 번째로 말씀드리고 싶은 점은 국제 협력을 통한 방법론의 통일화입니다. 각기 다른 기관이 다른 방법을 통해서 시료를 채취하고 분석을 하게 되면 서로 데이터의 비교가 서로 어렵게 됩니다. 그리고 어떤 같은 현상을 봐도 해석이 일관되지 않을 수 있습니다. 그렇기 때문에 국제 협력을 통한 방법론의 표준화는 매우 중요한 이슈입니다. 그리고 세 번째로 국제 협력을 통해서 북극 연구의 시간적, 공간적 공백을 메울 수 있습니다. 한 나라가 북극해 연구를 수행하면 어떤 그 모니터링의 역량의 한계가 있기 때문에 공동적으로 국제 연구를 수행한다면 보다 광범위하고 지속적인 모니터링이 가능하다고 생각합니다. 예를 들면 아까 예에서도 나왔지만 시놉틱 아크틱 서베이는 각 나라가 각 연구 구역을 분담하고 어떤 측정 항목을 다 분담해서 각자의 연구를 수행한 뒤에 지금 현재 데이터를 다 이렇게 통합하고 있고 지금 현재 논문 작성 중에 있습니다. 그렇기 때문에 시놉틱 아크틱 서베이 같은 다양한 북극 공동 프로젝트는 북극 전반을 포괄적이고 종합적으로 이해하는 데 아주 큰 도움이 될 것이라고 생각합니다. 이상입니다.
Then my next question goes to Dr. Yong-sik Chung. Michael showed actually your research in Greenland. Could you please comment on the value of collaborative research in Greenland?
예. 먼저 극지연구소와 이 DTU 스페이스 아까 린덴 베를레 박사님께서 말씀을 해주셨는데 이 DTU 스페이스가 수행하고 있는 이 협력 연구는 앞서 소개되었던 그린란드 남서부에 위치하고 있는 그 칸가루 수학에 있는 러셀 빙하 말단부를 대상으로 협력 연구가 진행이 되고 있습니다. 또 이 연구를 통해서 저희는 이곳에서 발생하는 환경 변화를 모니터링하고 이해하는데 가장 큰 중점을 두고 있고요. 주로 저희는 그 무인기와 위성 데이터를 활용을 해서 빙하의 후퇴 그리고 토양 수분 변화, 식생 변화, 하천의 발달 양상을 정밀하게 분석하고 있고 이를 통해 북극 빙하 감소 환경의 발달 양상을 체계적으로 파악하고 있습니다. 특히 이 연구는 기후 변화가 이 그린란드 빙하 감소뿐만 아니라 그 주변 생태계에 미치는 영향을 구체적으로 밝혀내는데 중요한 역할을 하고 있다고 말씀드릴 수 있겠습니다. 예를 들어 고해상도의 무인기, 라이다, 광학이나 분광 자료의 획득을 통해서 시간에 따라 변화하는 이 빙하의 동태를 굉장히 정밀하게 추적하고 이를 어떤 기후 변화 요인 혹은 지표 변화 요인과 연계하여 분석함으로써 빙하 환경의 변화에 미치는 주요 영향 인자가 무엇인가에 대해서 확인하고자 노력하고 있고요. 더불어서 이 협력 연구는 한국, 덴마크, 그린란드가 함께 협력해서 그린란드에서 이루어지는 북극 과학을 한 단계 발전시키고 이상적인 과학적 협력 모델을 제시하는 데 또 다른 의미를 두고 있습니다. 이 연구가 북극 과학의 수준을 높이고 전 세계 환경 문제 해결에 기여할 수 있을 것이라고 생각합니다. 이상입니다.
Yes, it's perfectly appropriate to hear Greenlandic perspective. Jacob flew a long way, only from Beijing this time. So, Jacob, can you provide your evaluation on the value and significance of collaborative research in Greenland?
Thank you very much, Chair. It's a good question, as we have heard, and I'm not a scientist or a researcher or a climate expert. I'm a lawyer of education, and I mostly work with politics and diplomacy. But I'm also a Greenlander, and I'm also from Greenland, so of course I know what is our society, how it works, and what people are talking about and what people feel. So I don't think I will particularly try to comment on these presentations there has been and what you have said here in the panel. But I would like to highlight that I highly agree with Dr. Michael Wernle, who mentioned inclusiveness and ownership and cooperation with the local population. It is vital if you need a comprehensive and a good study. So I highly agree with him. In Greenland, we are not many people, as mentioned, and we don't have many researchers. So we need people and scientists, as has just been highlighted. Research in the Arctic and in Greenland must be the benefit for Greenland and the Arctic and the rest of the world. So Greenland is also a huge island, the world's largest island. So I think there's plenty of room for even doing more inclusiveness to the Greenlandic communities, to Greenlandic research stations. And also for your question on the collaboration, that research and science diplomacy can also be used to develop our bilateral relations with other countries. And at the same time to benefit the Greenlandic scientific communities. And that is why we also have another aspect, so to say, of our slogan in our new strategy, which is nothing about us without us, that you have seen and can dig more into.
All right, then my next question goes to Dr. Wang in Canada. We all know a variety of Arctic research is being undertaken in Canada. Could you please introduce one best sample case of collaborative research project funded by NRC Canada and explain why and how NRC values international collaboration, please?
Yes, thank you, Chairman. So the NRC is actively collaborating with various countries, organizations to improve state-of-the-art technologies. One of them that I'd like to introduce today is the EMUSAT, the scientific cooperation agreement between the European Organization for the Exploitation of Meteorological Satellites, which is called the EMUSAT, and the National Research Council of Canada has been established to create a framework for collaboration to enable cooperative activity of mutual interest. EMUSAT is an intergovernmental organization based in Germany with the 30 member states. And EMUSAT operates the geostationary, polar orbiting, and the sea-level monitoring satellite. So data and products from EMUSAT satellites are vital to weather forecasting and make a significant contribution to the monitoring of the environment and climate change, including polar regions. The scientific cooperation agreement will give NRC access to this data and these products, along with the EMUSAT scientific expertise and the training of the NRC staff for use in its research, operational activities, and environmental digital twinning models. In return, NRC researchers will assist EMUSAT with the data validations, provide feedback on the data utility, and undertake a joint research. This collaboration will also give the NRC access to meteorological agencies of the EMUSAT 30 member states and allow member state meteorological agencies to identify and pursue opportunity for research collaboration with the NRC. So I think the importance of the international collaborative research lies in enabling access to diverse expertise and resources. Any lack of expertise or resources within the NRC can be addressed. Consequently, it will drive innovative and creative research, which will impact the quality of the research. Additionally, it also shares the cost and risk for the new research, making it easier to initiate and progress with less pressure. It will also widen our research network and co-publish the work to the broader audience to make more impact. Thank you.
Now we learned research collaboration goes all directions, Korea, Norway, Denmark, Greenland. Now, from Canada to Europe, and space agency in Europe. So let us talk about knowledge sharing and knowledge combining. So my question then goes to Yong-sik. From Michael's presentation, it was impressive to see the combined use of unmanned vehicle and satellite data. Could you please explain a little more about the integrated combined use of unmanned vehicle and satellite, please?
예. 극지연구소하고 그 DTU 스페이스가 현재 협력해서 무인기와 위성 데이터의 복합 활용을 시도하는 연구는 어떻게 보면 굉장히 최신 기술을 활용한 북극 환경 연구의 새로운 지평을 열었다라는 점에서 큰 의미를 가진다고 생각합니다. 먼저 무인기 같은 경우는 초고 해상도의 세밀한 그리고 정밀한 이런 관측 데이터를 제공할 수 있기 때문에 이런 정보를 바탕으로 빙하 표면의 균열의 변화, 식생 면적의 확장, 그리고 또 토양 수분 함유량 분포와 같은 이런 미세한 변화를 포착하는데 큰 장점을 제공할 수 있고요. 또 반면에 위성 데이터는 굉장히 광범위한 지역을 장기적이고 지속적으로 관측을 가능하게 하고 그 연구 지역 전반의 변화를 살펴보는데 강점을 가진다고 말씀드릴 수 있겠습니다. 이 두 가지 기술의 통합은 이 빙하 용융 환경을 대상으로 발생하는 다양한 환경 변화를 굉장히 다양한 시각으로 다각도로 분석할 수 있겠습니다. 예를 들어 무인기 데이터를 기반으로 제작된 정밀한 3차원의 지형 모델은 위성 데이터가 가지는 어떤 한계점들을 보완하고 전반적인 지표 변화를 보다 정확하게 이해할 수 있도록 도울 수 있고요. 이러한 기술은 또 기후 변화로 인해서 환경 변화의 과정을 보다 더 구체적으로 시뮬레이션 할 수 있는 기초 자료로서 활용이 될 수 있습니다. 이러한 기술 정보의 복합 활용 기반의 접근이 북극뿐만 아니라 굉장히 다양한 또 다른 어떤 극지 연구 영역, 산악 지형의 빙하 연구나 아니면 또 피오르드 지형이나 해안선 침식 변화 연구들과 같이 이런 다양한 지역을 대상으로 하는 극지 연구에도 활용성이 굉장히 높다고 말씀드릴 수 있을 뿐만 아니라 나아가서 어떤 환경 변화의 재난 경고 시스템에 또 탑재가 되면 굉장히 유용하게 활용될 수 있을 거라고 생각합니다. 결론적으로 이 극지연구소와 DTU 스페이스의 기술 정보 통합 기반의 협력 연구는 북극 연구뿐만 아니라 세계적으로 지속 가능한 환경 관리를 위한 다양한 또 새로운 방법론을 제시했다고 말씀드릴 수 있겠습니다. 이는 앞으로 다양한 환경 연구와 기후 변화 대응 전략 수립에 있어서 큰 기여를 할 수 있을 것이라고 생각됩니다. 이상입니다.
Thank you. Let me ask Dr. Wang in Canada. I heard you are yourself a part of collaborative research between NRC Canada and Memorial University on the topic of applying new technology in Arctic sea ice research, partly engineering. Could you briefly introduce your ice engineering research, focusing on the added value of new techniques, please?
Yes, thank you, Chairman. So the NRC and Memorial University collaboration is mainly focused on the measurement of the ice property from the ships, such as icebreakers. So we use LiDARs, ice radars, EM sensors, ice coring, and the stereo camera system, as well as all ship performance measurement from propulsion system, propeller thrust, torque, RPM, and also ship speed and ship motions, etc. So NRC and Memorial have a collaborative center called a colleague space, which enables us to work together without any tedious bureaucratic process, which is, sometimes the paperwork takes forever. But we just cut down those processes. So we have been collaborating in this space since 2019, and the various topics have been covered, such as hydrobuffering effect of the ship-iceberg interactions, icebreakers, friction reduction using an air bubble systems, the effect of the plane stress on the fracture strength of ice, development of the various icebreaker performance prediction models, including machine learning and AI, full-scale performance measurements to use a ship as a sensor, development of the decision support system for autonomous surface ships, and so on. So this collaborative research effort aims to improve ship performance in Arctic or ice-covered water to reduce emissions, as well as to provide accurate ice modeling to help us make optimal decisions to navigate through various ice conditions without compromising the missions. So from the ice mechanics standpoint, there is added value from this research effort. For example, the fracture strength of the ice is affected by in-plane stress, which wasn't really considered before. And this discovery can be applied to a pressured ice field, which is often you can see in the ice field. Once ice field is under pressure, the apparent fracture strength increases, and this could influence the icebreaker's operations. This understanding helps other research topics such as the decision support system to optimize fuel consumptions. Another interesting research topic is the air bubbler system for icebreaker, which can reduce total ice resistance under a certain ice condition using air bubble system underneath. So a better understanding of these phenomena can help design and operate the new icebreakers with lower operational cost while improving their ice-breaking capability. Thank you.
Thank you. It still sounds very technical to me. Tell us, Dr. Jung. I recall in Torres' representation, I recall Torres' representation, ocean acidification in Kongsfjorden. As I said, it already sounds very technical. How can you explain such complex findings to local people or international policymakers? How can you do that?
오케이. 저기 일단 해양 산성화에 대해서 잠시 말씀을 드리면 해양 산성화는 북극해에서 상당히 북극해를 상당히 취약하게 만드는 현상 중에 하나입니다. 그 이유는 해빙이 급격하게 감소하면서 해수면이 대기 중에 더 많이 노출되고 대기 중에 있는 이산화탄소가 해양으로 흡수되기 때문입니다. 그리고 게다가 더 다른 이유는 이제 해양 그 햇빛이 더 많이 이제 광량이 이제 해수면으로 도달되면서 해양 기온의 유기물이 생성되고 그리고 그 영구 동토층이 높고 그리고 하천수 유입량이 증가하면서 육상 기온의 유기물이 북극해로 상당히 많이 유입되기 때문에 이들 유기물이 분해되는 데에서도 이산화탄소가 발생하기 때문에 북극해는 해양 산성화에 상당히 취약할 수 있습니다. 그리고 이러한 과학적 현상을 정책 입안자들이나 북극 현지 주민들에게 설명하기 위해서는 맞춤형 접근 방법이 좀 필요할 것 같습니다. 먼저 북극 현지 지역 사회에는 과학을 그들의 삶과 연결시켜서 설명할 필요가 있습니다. 예를 들면 해양 산성화를 예를 들면 해양 산성화에 의해서 그들의 식량과 어떤 소득의 원천이 되는 어족이 어떻게 영향을 받고 어떻게 개체수가 감소할 수 있으며 그것이 어떻게 그들의 삶에 영향을 주는지에 대한 어떤 그런 이해도를 높일 필요가 있습니다. 그리고 정책 입안자들에게는 좀 더 다른 접근 방법이 필요한데 기술적으로 세부적으로 접근하기보다는 어떤 종합적이고 넓은 이해를 설명하도록 노력하고 그리고 좀 더 그 문제의 심각성과 문제의 심각성과 그리고 현재 연구로서 발견된 새로운 지식을 업데이트해 줌으로써 그들이 그 저희의 연구의 중요성을 깨닫게 해주는 것이 더 중요하다고 생각합니다. 그리고 또한 어떤 글로벌적인 정책 이슈와도 연결시켜서 예를 들면 뭐 UN 기후변화 협약 등과 같은 그런 글로벌 정책 변화들과 연계시켜서 북극 이슈를 계속 상기시켜서 북극 연구의 중요성을 북극 연구의 중요성에 대해서 관심을 촉구하는 것이 중요하다고 생각합니다.
Okay, so how this kind of science, including ocean acidification, how this kind of science becomes useful to people who live in the Arctic. So I have two questions in a row to Jacob. The first one is, okay, we saw there are extensive observation, modern science, Western science observation networks in Atlantic, Arctic waters, sometimes close to Greenland coast. What kind of opinion will this local community hold on these efforts, and that can it go with traditional resource use by these communities? Second question is, how this research are currently being delivered and communicated to Arctic communities? Is it done in a timely manner, and what is the real status?
Thank you. Typically, if a research vessel comes through the fjords, as we talked about, or into inhabited places, probably most of the local people will find it annoying. Maybe they claim that it's disturbing the traditional hunting and fisheries in the areas. But maybe they will also be happy if a research vessel can break some ice, and then the local shipping company can come in with fresh food and other products. So it really depends on what you're doing and conductive and how to involve them. I think also it's important to give incentives to collaborate and involve the local population and to make them understand why and how it will benefit them. Because, of course, people living in the local communities or in the Arctic is not stupid. They are having probably a huge IQ on how to survive in these areas compared to many other people. So I don't think it's a question of they are not interested in Western science. I think it is a matter on how you present it to the people and how they can benefit from them. Because what are they doing? They're typically surviving. And how are they surviving? They're hunting, they're fishing, they're earning money. They have to sell the fish and seals and so on. So of course, if something comes in to disturb them where they cannot go out and do these things, it's a bad thing. So to cooperate with them and make them understand how it will benefit them, then I think you will come a long way. And one of the things to do that is, of course, the government of Greenland can introduce some legislations and some guidelines, some ethical guidelines to do that. But also, I will mention that we have the Arctic Hub, which is co-financed by Denmark and by Greenland, which is situated in Nuuk, which is doing matchmaking between international scientists and research projects and local communities and local scientists and local research institutions. So that's maybe a way to secure that you can do to have a good start when you're doing research.
Okay, then let me ask the opposite direction. Maybe Jin-young can help us. I know you are not an ecologist, but a chemist. But will this kind of ecological knowledge by Arctic people, by Arctic indigenous people, can help your observation and your planning? Can you comment on that, please?
예, 질문에 대해서 말씀드리면 북극 원주민들은 그들의 생태 지식은 매우 가치 있는 자원이 될 수 있습니다. 예를 들면 그들은 세대에 걸쳐서 특정 환경의 변화를 아주 잘 관찰해 왔고 그것을 그들의 삶에 반영하고 있습니다. 그렇기 때문에 그들의 생태 지식은 과학적인 데이터를 뒷받침하거나 해석하는데 서로 상호 보완적이 될 수 있습니다. 예를 들면 연구를 계획할 때 그들의 지식을 경청하고 먼저 사전적으로 파악을 한다면 저희가 그들의 지식이 어떤 생물의 서식지의 변경이나 어떠한 이동 경로의 변화에 대한 지식을 갖고 있다면 샘플링 전략을 짤 때 그들의 지식을 반영하는 것이 더 효과적인 연구 계획과 성과로 이어질 수 있다고 생각합니다. 그렇기 때문에 저는 생태학자가 아니지만 그 생태계가 움직인다는 것은 물리적, 화학적 변화가 수반된다는 것이기 때문에 그들의 지식을 경청하고 이용하는 것이 서로 과학적인 지식을 더 뒷받침해 줄 수 있고 더 돋보이게 할 수 있는 그런 상태라고 생각합니다. 그리고 그들을 또한 저희 연구 작업으로 이렇게 같이 샘플링을 같이 한다던가 연구 작업에 협력을 하게 함으로써 그들의 어떤 지식은 어떤 저희가 관측적으로 이렇게 잘 캐치를 할 수 없기 때문에 그들의 지식을 잘 활용하면 저희 연구에도 상당한 도움이 될 수 있을 것이라고 생각이 됩니다. 예, 이상입니다.
Then I should ask Yong-sik about, let's say, you have been doing research using drone, satellite, Greenland, but you also mentioned hydrological cycle in Greenland. Can you briefly mention on the potential benefits that Greenland community can expect out of your research? Can you comment on that, please?
예, 답변을 드리겠습니다. 저희는 앞서 말씀드렸던 이런 연구를 통해서 그린랜드 지역 사회가 기후 변화로 인해서 직면한 환경적인 어떤 문제를 이해하고 해결하는데 필요한 과학적 데이터를 제공하자라는 데 어떤 큰 의도를 가지고 있다고 말씀드릴 수 있겠습니다. 가령 빙하가 녹으며 생성된 용융수, 즉 담수 자원의 흐름을 분석하거나 기후 변화로 확장되고 있는 식생 면적에 대한 정보를 제공함으로써 지역 생태계 관리와 자원 활용 계획 수립에 도움을 줄 수 있다고 생각하고 있고요. 또한 이 획득한 그리고 또 저희들이 분석한 이 연구 자료들은 지역 정책 개발과 환경 관리 전략 수립에 활용될 수 있을 것이라고 생각합니다. 빙하 용융수가 말씀드렸다시피 어떤 흘러서 저장되는 어떤 지형적인 거시적인 또 그리고 미세한 어떤 그런 관점에서의 결과들 그리고 또 농업에 적합할 수 있는 어떤 잠재적 지역을 제한함으로써 지역 주민들이 기후 변화에 효과적으로 대응할 수 있도록 지원하고자 하는 어떤 의도를 가지고 연구를 진행하고 있고요. 다시 말해서 이 프로젝트는 단순히 데이터를 수집하는 것에 그치지 않고 지역 사회가 장기적으로 기후 변화에 적응하고 지속 가능한 발전을 이룰 수 있도록 기초를 마련하는데 초점을 맞추고 있다라고 말씀드릴 수 있겠습니다. 감사합니다.
I'm very, very wary and mindful of the remaining time. So this should be my last question to Dr. Wang. I know I have been impressed by Canadian approach that they're so respectful about indigenous knowledge. So what is your agency, National Research Council of Canada? What do you do? What are you doing to promote partnership between science and indigenous communities, please?
Yes, there have been various programs to support indigenous and northern peoples in improving their quality of life. So from 2017 to 2022, NRC, they initiated a program called the Arctic Program to help understand Arctic development. So this program involved partners from government, indigenous, and the northern community, industries, and academia, and sought to address opportunities and challenges to support sustainable and low-impact development of the North, while increasing the quality of the life for the Northerners. In addition, NRC joined a CNUC project. CNUC stands for a Canada, Inuit, Nunavut, United Kingdoms. So there's three different entities or collaborating. A research program which spans from 2021 to 2025. This CNUC has 13 projects with various research themes, including health, food, ecosystems, search and rescue, and safety, etc. Recently, NRC initiated another challenge program called the Arctic and Northern Challenge Program, which started 2022 will be end the 2029, which is going to be a 7-year program, which works with the Canadians and international partners from Northern community, academia, industry, government, and other interested stakeholders. Research conducted under this program will examine 4 research themes and the 2 cross-cutting area. These 4 research themes are the housing, the food, the health, and water. So how we improve those 4 different areas for the indigenous people. While the 2 cross-cutting areas are capacity building and the indigenous knowledge. This challenge program is collaborating with international partners to support about $150,000 per year for 3 years. So this unique condition of this program is that proposed research have to include a partnership with the northern community. So have to include the northern community, but you can have international people can collaborate and to apply. We also developed a cultural competence course, which is a very interesting one that we actually made this one for this Northern Challenge program. So it's for all the successful proponents to complete this course in order to understand cultural diversity. So before we have some misunderstanding between people and we work with indigenous people, so there is some cultural gaps and we didn't capture that part. And then we recognize the importance of this cultural diversity. To date, 15 projects have been received funding from this program. And currently we are open for proposal for next 3 years work. I think the proposal will end the early next year. So please check NRC website if you are interested in. Besides the NRC, Polar Knowledge Canada is also providing funding for similar research topics. Thank you.
I think we can wrap it up, not in haste, but in good manner. My conclusion today, when I first began incorporating human in the Arctic science, or adding human dimension, it sounded very overwhelming, challenging, but I now feel it's not just worthwhile to do this, but it's more doable and more tangible. With this, I conclude this roundtable discussion and pass the microphone back to Anna, please.
And thank you to all of our panelists. Now we will have a short 5-minute break before continuing with our final session, the Arctic Policy Forum. So please return back to your seats by 1700 hours. Thank you.